Hello everyone, welcome to the Lab5. In this lab, we will be talking about BigQuery. So I will introduce BigQuery, discuss some features of BigQuery, and actually run some SQL queries on the BigQuery platform. So first, what is BigQuery? Well, BigQuery is a fully management data warehouse provided by Google Cloud Platform, or GCP. So you can use SQL queries to manage and analyze data, and that data generally has a large scale, for example, in petabytes. And it has a distributed architecture, so it has like high fault tolerance. It's also scalable, so the performance is guaranteed. Also, it's serverless, which basically means the service provider, in this case, Google Cloud Platform, takes the most operational responsibilities for you, like infrastructure management, networking, storage, load balancing, failover, and auto scaling. So for developers, it's like there is no server needs to be managed at all. They can just focus more on the business logic and the coding part. And of course, it has high performance. You can query terabytes in seconds and petabytes in minutes. And this is written in their service level agreement, which means performance is guaranteed. So BigQuery stores data in a columnar storage format, which is good for querying a subset of columns, but it's not very efficient to insert new data. But of course, BigQuery is mainly used for querying data, and we have other tools on GCP for you to gather and store data. And data on BigQuery usually has many replicas located in different regions. So it has high availability and fault tolerance, right? And BigQuery provides many fully managed tools for like machine learning, business intelligence, and GIS. And of course, it has a well-defined API. In terms of pricing, BigQuery leverages a pay-as-you-go billing model, so it's cost-effective. Also, there are plenty of public datasets available on BigQuery, which means everyone can access and run queries on these public datasets. So in this lab, we will run some SQL queries using BigQuery, but before you do that, you need to register for a Google Cloud Platform account, and GCP actually provides some free tier for users. You can query up to 1 terabytes of data per month for free. Also, you can use the BigQuery sandbox to get familiar with GCP and BigQuery without charge. And in this lab, we will use the torrent dataset, which is a dataset about the questions, answers, posts, users, and code snippets on Stack Overflow. So you can use this dataset to do some empirical software engineering research, like analyzing the evolution or trends of different programming languages or operating systems or the developer communities, something like that. And you can find the documentation of the torrent dataset here, and it is also available on BigQuery as a public dataset. So we are going to run some queries using the BigQuery platform and this torrent dataset. So first we need to open the GCP console. Okay, so our first query would be how many authors are there on Stack Overflow? So you just need to query the posts table and count the unique owner user ID, right? That unique owner user ID represents each author on Stack Overflow. So let's run this. So the table should be the posts table. And we actually count distinct owner user ID, which is an attribute in this table. And we run this query. You see it's really fast, right? And there are like over 5 million authors on Stack Overflow, right? And the second query, number of code blocks on Stack Overflow. So we just need to query the blocks table, and we just need to count how many IDs are there in the blocks table, right? So the table should be post block version, and I'm gonna count the ID. Okay, so there are like over 250 million code blocks on Stack Overflow, right? And the third query would be the number of lines of code on Stack Overflow. So we need to get the number of lines in each code block, and then we calculate the sum, right? So the table is still the blocks, and we need to calculate the sum of the line count of each code block. And we run this query. As you can see, it's really fast, right? And we have like 1.7 billion lines of code on Stack Overflow, right? And the next query would be how many posts are there without any answers? So we need to query the posts table, and the post must be a question. So the post ID, post type ID should be 1, and the post should not have any answer, and which means the answer count is 0. And then we count the ID. So let's run this query. I should query the posts table, and the post type should be a question, and the question should not have any answer. So the answer count should be equal to 0. And we count the ID, look at the number of posts satisfying these conditions, right? Oops. So there are like 3 million posts without any answers on Stack Overflow, right? And the next query would be how many types of badges are there? So Stack Overflow may award users with badges, right? I mean, if users did a great job, like they have posted many high quality answers and have a good reputation, something like that, right? So we query the badges table. So the table should be badges. And count how many unique names in that table, right? So that we can get how many types of badges on Stack Overflow. And the name should be distinct. And we run this query. So you see there are like over 6,000 different badges on Stack Overflow. And of course, we can analyze some trends using BigQuery, like how many questions are posted each year on Stack Overflow. So we query the post table, and the post ID or the post type ID should be a question, right? Then it should be 1, and we extract the year from the creation date, right? And we then group the data by year of creation. So we extract the year as year, and we group the data by year, and then each year we count the post type ID so that we can get the number of posts posted in each year, right? And we order the data by the creation year and in descending order. Right? So let's run this query. As you can see, we get the results in 1.3 seconds, which is really fast. And of course, we can query the number of answers posted in each year from 2008 to 2020 on Stack Overflow. We just need to replace the post type ID here with 2, which represents answers. And we run this query. This is really fast, and we get the results. And if we draw a line chart to compare the number of questions with the answers, and we can get a chart like this. As you can see, the number of questions and the number of answers are increasing really fast. And of course, there are more answers than questions because a question may have like multiple answers, right? Okay, so as you can see, we run some queries using the BigQuery platform, and all those like query jobs can be completed like within 10 seconds or in seconds. So BigQuery is very powerful, right? It has like high performance, and you can run like standard SQL queries on the BigQuery platform to find the answers to the questions you want to explore. And there are many public datasets on BigQuery, and it has like really high performance, as you can see. And because it has a distributed and serverless architecture, and of course the columnar data formats. So you can refer to these websites for more information about BigQuery, and I recommend you register for a GCP account and give it a shot. Again, if you have any technical issues, please post your questions on the course forum. Thank you for watching. See you in the next slide.